Yeah, let's see if it is up or not. On YouTube it is, on Twitter it is. Okay, let me tweet and then we can start. Also, let me reset the timer. Okay, I am. Uh, I can like go ahead now. So we were going through concepts yesterday, and we do have we have read the this page. So we need to go through next, and this is the final concept. Then maybe we should check how the relayer works. So relayer is here, and then finally we can start like actually using across. Let's see. I don't want to use UI. UI is not that interesting for me. It can be for you guys, but for me it's not that interesting. So I want to skip it. If if you want to go through it, we can. Let me know. Pretty sure no one is watching. So anyway, if you want me to go through UI and how to use across SDK to build a UI, we can. If you don't want to, if you don't tell me, or if you don't want to, I can just go through contracts directly and read the code itself and build something with it. So what's here? Okay, let's go through canonical asset maximalism. Canonical assets are the only secure way to represent value across chain. Intent bridges like across enable interoperability with canonical assets at faster speeds and lower third party messaging faster speeds than third party messaging bridges without security trade offs. Okay, how is it better? The security, they are saying without security trade offs, so we need to go through that. Escalator. Oh, let me open this. How how intent based bridges are better than messaging bridges that use messaging question mark. That's one of the question. Okay, understanding canonical assets. Canonical assets refer to original or native form of a token on its home blockchain. Okay, in the context of interoperability, tokens can either be canonical or representative. The distinct Distinction generally comes down to trust assumptions in secure assets on secondary chains. Okay, so I guess canonical is canonical is the original refers to original or native form of token on its home blockchain. I don't. So it's difference between USDC and USDC dot bridge USDC. So we have this right, bridged USDC Arbitrum. Yeah, you see USDC dot E. So just a second. Okay, so we were talking. Ignore this. I do not recommend whatever this is. I think it's a gambling site, so fuck that. I was talking about this. So bridge USDC and USDC. So that's like canonical and representative. How assets move between chain, regardless of chain interoperability protocol or technology. Interoperability protocol or technology. There is only singular way to move assets from its native chain to secondary chain, and it's not really moving at all. Locking or burning token on its native chain, the origin chain, sending message to origin from origin chain to destination chain after the locking or burning is complete, minting new token on destination chain. So yeah, we already know how bridging works. Most of us, I guess. If you don't know, it's let's like draw thing. So we have this chain A, chain B, chain A, then there is chain B. Let me. Yeah, so there is a contract on chain A. Let's say contract. If you want to bridge from chain A to chain B, what we have to do is first send tokens to user. User send token to the contract to be locked. Then it's locked, and there is some kind of messaging protocol. Some kind of messaging protocol or a trusted third party which which calls contract on chain B. Why I'm saying trusted third party is because we do have like messaging protocols like Hyperlane. It's not there are multiple like wormhole, Hyperlane, layer 0 or layer 0, but there are also some tokens like WBTC, which are held like BTC is held by some third party in multisig on Bitcoin, and then they mint the WBTC on Ethereum. So there is a third party involved sometimes, and then here at last we contract sends token bridged token bridge tokens to what is bridge tokens to the user. So there are two ways to go about it, right? So this is locked, but we talked about locking the tokens, but there is also another way where both of, both of the contracts have same admin. Again, it's a similar to WBTC, or better, similar to USDC. Both of the contracts have some kind of admin uh, or manager who we all trust, or there are some trust assumptions there, who burns the contract on chain A and sends the mints the tokens on chain B. So it's not that difficult, but sometimes like there are different trade-offs. Like, do you want to trust WBTC managers with your tokens? If not, then there is no way to go about it, I guess. Okay, so we have talked about this. Okay, critical component in above flow is step 2, specifically the verification process, ensuring the message is not faulty. The verification method used is precisely what distinguishes canonical versus representative assets. At the highest level, there are two verification methods. Via canonical bridge contracts, which underpin the security of an L2 chain that inherits the security from mainnet Ethereum in the most trust minimized way is responsible for verifying messages to mint token. These are considered canonical tokens, given they do not increase trust assumptions versus simply using L2s. Similar to trustless verification mechanisms may exist from Ethereum to other alt L1 chains. Okay, we understood that. It's the same thing. So it's sending Ethereum from when we send ETH from Ethereum to Arbitrum, it's canonical. Next, via third-party messaging bridges. A third-party bridge, which can have number of trust models, is responsible for verifying messages to mint tokens. These are considered representative tokens, given they do not increase trust assumptions, as users now have to trust a third party to never allow faulty message, and if they do, it could result in infinite mint and unbacked tokens on secondary chain. Okay, so messaging is like you are using some kind of messaging protocol, and it's saying like if that messaging protocol doesn't have correct trust assumptions, or there is some kind of fault there, it could backfire. Okay, that's what I'm saying. If you use Arbitrum bridge, it's canonical. If you use something else, it's representative token. Canonical asset maximalism. In a trust minimized world, only canonical bridges and only canonical assets would be used. But current speed of canonical bridges, 1 hour to 7 days, makes them untenable solutions for many applications. Third-party message bridges can be faster, but they can they can come with security trade-offs inherent in minting representative assets. Okay, so what they're saying is, right now if you go to Arbitrum bridge, like the one Arbitrum provides, you can deposit quickly. It's maybe few minutes, but if you want to remove it, it takes 7 days, because I, uh, I think it's optimistic rollup, and optimistic rollup has some kind of withdrawal period where user, sorry, where user, no, not user, the whole blockchain where has like period where they someone can like raise a request saying the proof, like fraud proof, or the proof is not correct, something like that. Not exactly, but there is a delay in cross checking it. Not sorry, delay. There is delay in withdrawal of assets. So uh, if it takes 7 days, like it's not very you. Sorry, if it's taking 7 days, then it's very much likely like most of the people won't use it. Then across this intent based bridge introduces a architecture in interoperability that doesn't suffer from security hurdles of messages third party message bridges, and is empirically faster and cheaper than canonical bridges. Across achieves this by inserting third party relays to quickly fill users bridging request. Okay, we are here to quickly fill users bridging requests using their own inventory of canonical assets, and a settlement layer that sits on top of canonical bridges to slowly verify and repay relays. In other words, across this intent across this intent bridge decouples urgent needs of fast filling users from eventual need of verification. User and developers don't need to make sorry user users and developers don't need to make the trust versus convenience trade-off in canonical versus representative assets. Intent systems like across offer best of both worlds. Okay, we understood like what intents are, and now they're just telling us like why canonical assets are important, because they have better trust assumptions than representative assets. And another thing is, when you use intent, someone else uses their canonical assets instead of you. So that's the gist of it. Okay, we understood this. We have gone through all of the what is this concepts. Next part is actually going through code, or let's go through docs and see what else is interesting here. Should I use API versus app SDK to integrate across? We recommend using app SDK as for the easiest way to integrate. Okay, depending on the context, across will sometimes send user ETH and sometimes send you WETH. If user puts ETH and EOA, okay, so they're saying like what asset should be received, ETH or WETH. If user is sending ETH and on destination chain, it's EOA, then they are sending ETH. If it's contract, then they are sending WETH. And if user is sending WETH, in any case, they are getting WETH. Okay. How do I deposit using ETH instead of WETH? Native token for the network set message equal to input amount. To WETH set. Okay. Input amount should be same, and the input token should be address of WETH on the current. Okay. We have to like actually go through. Let's go through API. Okay. Across dot to slash API slash limits. It's limits, right? You can retrieve the current limits of protocol on testnet. Oh, it's only for testnet. Is it? Testnet. What? Oh, okay. We message invalid parameter at path destination chain ID expect positive inst. Okay. We need to actually send some data, I guess. Control F. Limits. Send. Okay, route is not there. Can we say input as just zero address Ethereum? Copy. Oh, we need to add a value. Okay, ignore this. We need to change multiple things. All the available routes. Can we test it? How many routes are available? A lot of them. Yeah, a lot of them. Deposit status. Chain ID. Deposit ID. Okay. Yesterday we saw. Yesterday we saw our deposit, right? So what was that? Base scan. Yeah, base scan Sapolia. And it was this or this. So let's see how we can get the ID. Yeah, internal logs, deposit, depositor. We have the ID. Okay. So we also need, if we want to check the guaranteed, sorry, if you want to check status of the status of the intent, you need to know this value. We have the event and we can just listen to it to get it. Okay. uh, Index topic 2. Okay, topic 1, topic 2, and topic 3. We want to listen to topic 2, want to listen to funds deposited and topic 2 for following the status. Get all the deposits for given depositors. Test it. Optional. Okay, we have bunch of them. Fees, suggested fees. Okay, retrieve suggested fee code for deposit. Minimum deposit, maximum deposit, relay fee, relay capital fee, relay gas fee, LP fee. Is the amount too low? Okay, we have multiple fees, so 1, 2, 3, 4, and I guess it's combination of all of them. Let's see. Yeah, returns suggested fee based on input output. Okay. Also includes data used for data used to compute the fees. Output token, message, relay, timestamp. LP fee percentage, I guess. This PTC is LP fee percentage. Okay, percentage of the percentage of transfer amounts that should go to relays as fee in total. The value is inclusive of fee percentage, and it's 16 decimal point. Total, what's relay capital fee? Should go to relay as fee cover. Then gas fees, percentage of amount that will go to LP as fee for borrowing their funds. We don't know how the total fee is calculated. I'm assuming addition of all of these, but if not, I have to check. Okay, so this is 16 decimal, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 16, so 0.03%. Did we send the amount? Okay, yeah, we did send the amount. Yeah, then we can start writing. I guess there is nothing else. We can just start writing the code to get like a script to get tokens from one chain to another, and we are going to use testnet, not the mainnet. So keep that in mind. Where developer support, bug bounty. Yeah, there is bug bounty. We can. I'm pretty sure audits. There are multiple audits. Yeah. 1, 2, 3, 4. Let's just read about this. As we are gonna go through all the code of the smart contract, so why not learn like what issues were there? Okay, all of them were. There was no high or what was critical. All of them were medium. Sorry, I forgot to zoom in. Okay. Relay tokens function blast adapter contract is responsible for bridging tokens from Ethereum to blast. In order to do that, it uses either L1 standard bridge or L1 blast bridge, depending on token that is being bridged. In case of DAI, an attempt to call deposit ERC-72 function of L1 blast bridge is made. However, bridge does not contain this function. This means that all transactions trying to bridge DAI to blast using relay token function will revert. DAI is being bridged. Consider calling bridge. Oh, they just called wrong function. Okay, that's understandable. It's not that big of a deal. Okay, let's ignore this. Let's go to their GitHub. Oh, sorry. Uh, I, I I remember I talked about going through Relay and how it works. Installation, environment. Okay, Relay. Okay, going through Relay doesn't make sense right now because this is just technical. The whole thing is very technical. If we run our if we run our what is this? If we run our relay around testnet, uh, we can learn about it, like how it actually works, how to set it up on VPS, etc. We had one question yesterday. Where was it? This is the question: how exclusive relays are selected. We talked about exclusive relays yesterday when we saw the transaction data. Sorry, transaction call data, yeah. And in there was exclusive relay. On testnet it's not exclusive, it's exclusive relay doesn't have any address, it's zero address. But on mainnet it does, on any mainnet. So that's what we want to see, like how the exclusivity works. What is relay? Sorry, the exclusive relay is chosen from the relay nominations, and will read about the nominations right now. What is relay nomination? Relay nomination or relay exclusivity provides a single relay with time limited period of exclusivity to fill a given deposit. Exclusivity is assigned at deposit time via exclusive relay and exclusivity deadline. Both the things, both the fields are there. Exclusive relay, and I don't know if exclusivity parameter is there. We don't have this field, exclusivity deadline. Maybe it's older field. Sorry, the older version of contract had this field, so that's why it's here. Arguments to and across deposit and emitted as part of V3 funds deposited events. Okay, let's see if we actually got just funds deposited, exclusive relay, and yeah, there is exclusivity deadline. We don't know how it's calculated. The exclusivity deadline is the field in the event, not in the input. Okay, next, what's next? Event. The exclusive relay address has until exclusivity deadline timestamp on destination chain to complete the fill with no risk of collision. If this deposit remains unfilled on destination chain beyond exclusivity deadline, then fill becomes available for other relays to complete. Okay. Why is this helpful? Speed-based relay competition can lead to collision and gas competition amongst relay. Many relay implementations have reached point of maturity where additional speed gain are difficult to unlock, increasingly encroach on original chain finality guarantees. Okay. Relay exclusivity provides a means of retaining the speed gain that across has unlocked for users while reducing uncertainty and risk of relay. Shit, I'm losing it. Relay exclusivity provides a means of retaining the speed gains that across has unlocked for user while less reducing uncertainty and risk for relays. Okay, understood. Relay exclusivity also provides a method of evaluating relay performance and in terms of speed and availability, and enables a pathway to future order flow preferencing. A relay are therefore incentivized to do following: ensure that their implementation respects exclusive relay and exclusivity deadline fields. Okay, ensuring we'll keep that in mind when we rewrite the relay. And ensure that they react promptly when their own relay address is specified on a new deposit. Okay, how does exclusivity work? Relays are nominated via across API. There are few steps to becoming eligible to receive exclusive flow. First step is First step is that relay can signal their desire to desire desire to be considered for nomination by submitting a pull request on exclusive relay configuration repository. Okay, this repository exists as an interim system in order to fast track rollout this in order to fast track the rollout of this program. Okay, we will check this repo. I, I do know what is there. Like, we have to create a JSON file with all the details of relay address and these fields. If these fields are there and they approve the pull request, there are multiple pull requests. 1, 2, 3, 4. Okay, but there are also few relay approved already. Let's check. Light. Okay, this, I don't know this guy, but he added one of the exclusive relay. Origin chain IDs is this. Max fill size is added here. Multiple things. So if we want to run exclusive relay, we have to be here, and team is approving, I guess, 2 weeks ago. So yeah, if you want to send it, you can go ahead and create that JSON file. Is it JSON file? I guess it's a JSON file. Yes, and run your relay. Let's see. Validate config. Okay, we can ignore this. Next part. That's the first part for becoming a nominated exclusive relay. Once a relayer has signal interest in becoming eligible for nomination, the relayer will begin receiving a bi-weekly score. The score that each relayer receives depends on few metrics: reliability on nominated fields. Okay, the first component of relay score is whether relay shows up to speed complete transactions that they were assigned. I don't. Okay. If a relay fulfills a high percentage of their assigned transactions, then they will have high score. If they do not, then they will have a low score. Okay. Speed on nominated fields. Second component of relay score is whether they fill the nominated field in timely fashion. Relay fill times are benchmarked against how fast a transaction would have been filled without exclusivity, because we want user experience to be excellent, independent of whether it's being fulfilled by nominated relay or being run via speed based fill system. Okay, they want to, first is reliability, how much percentage of intents you are filling, then how quickly you are filling, and then let's see, step in fills. The final component of relay score depends on relay's ability to step in and fill deposits that were missed by other nominated relays. For example, if 123 was nominated to make fill but didn't make the fill, by exclusivity deadline, then 234 could step in and make the fill, which would earn 234 points on relay score. Okay. Then if someone misses, you have to come in and fulfill those. Keep these things in mind, because when we write the relay, we need to think about these things. First things first thing is listening to multiple blockchain RPCs and getting the events, like listening to events on spoke pool, I think. Yeah, spoke pool, and acting accordingly. Next part is this one, where we have to keep the nomination, we have to optimize for the score. That's the second part. Okay. A relay that is new to nomination ecosystem will not be able to earn points from. Okay. Relay that is new to nomination ecosystem will not be able to earn points from 1 and 2, which means that they can only enter exclusive relay set by making step-in fills. They should also demonstrate via filling open order flow that can fill within an appropriate amount of time, i.e., if relay bot always takes 30 seconds to make a fill, then we are unlikely to add that relay to the set, given that the most fills expect sub 10 seconds transaction. I don't understand. New nomination. Okay, it's, but why they won't be new relay? Okay, I'm assuming when a relay is there, when you fill the JSON file and create a PR, you automatically get in and start getting exclusive relay or exclusivity rights, or getting nominated. But here they are saying you won't be able to earn points. That means you are not getting nominated. Then what's the point in creating the PR? I don't know. When selecting an let's go to next part. When selecting an exclusive relay for any particular deposit, the across API applies a selection process that considers a number of inputs, including relay's own configuration preferences, their token balances on destination chain, and their relay scores. The exact implementation and criteria for selection process is maintained by Risk Labs, is subject to change in order to optimize user experience and minimize externality that leak value from the system. Risk Lab, so this is just terms and condition. Like Risk Lab can do change the preferences for nomination. Yeah, and that's about it. Risk Lab can change nomination preferences to optimize for the user experience. That's what they are trying to say. When exclusivity is being rolled out, relay exclusivity is being rolled out incrementally in across API on select route in order to trial the system. At this point, the majority of flow coming from across FE front. Okay, majority of flow is coming from across FE is assigned an exclusive relay. Performance is continuously monitored by across team, and adjustments are made as requirement are made as required. Third-party integrators are expected to begin incorporating relay exclusivity by Q1 or Q2. So it should be out right now, and we do know it's out because we have multiple sorry yeah, we have multiple configs, right? Multiple relay addresses who want to get nominated here. Okay, that's pretty interesting. We did solve our question, which was how exclusivity works. It was here. So answer, check this. Check this. Okay, next we have 10 minutes left. If someone has any questions, I know one person is watching on YouTube other than me and my brother. So if you have any questions, let me know on Twitter. If some, I don't know how many people are actually watching on Twitter live. So if you have questions, put it in chat. Chat. Okay. Yeah, you can send messages here. If not, I'm gonna end the stream early today. Yeah, I'm gonna end the stream early today, and tomorrow we are gonna write a script that calls the across API, gets the particular gets the particular sorry that calls the across API with correct inputs and gets the fees, and we will calculate the fees, and then call the spoke pool, call the contract to deposit the funds, and listen to status of that particular intent. So that's tomorrow. We are actually gonna write the code from tomorrow onwards for last 3 days, last 2 days, and today we have been just learning about theory and how it works, but not actually writing any code. So that will change tomorrow, and hopefully you are as excited as me. And yeah, okay, that's about it. If you guys have any suggestions about how I can improve my streams, let me know in Twitter DMs, on YouTube comments, on I don't know, find my email and email me. Anyway, if you have any suggestions, I'm happy to listen to them and improve my streams. So please go ahead and do that. If you are not following me on Twitter or YouTube, please go and follow me on Twitter and subscribe on YouTube, because I have way too low of a follow count on Twitter and subscriber count on YouTube. So I would appreciate you following me. Next, what is next? Yeah, and have a nice day. See you guys tomorrow, same time. Okay, bye bye.